everyone, welcome back. We're already here at what I think is the fourth video in the series about this amplifier. Since the last video I have been pretty good at work. I replaced all the caps here on this big PCB. That PCB takes care of all the tone controls and the preamp for the phono preamp. So all the caps have been swapped, and I have to say the caps that came out there, they weren't great. They were all, let's say, around 40% out. Some of the caps also had a really high ESR. For example, the ones that I pulled from the phono preamp. This guy over here, it's a 68 microfarad cap. Here in the phono preamp, these had an ESR of 5 ohms, I believe. So these were pretty bad. And yeah, everything marked here in pink now is what I swapped out. So that's quite a lot. Yeah, pretty glad that I did, because these caps really needed to be swapped. So that's the first thing. Then what else? Oh yeah, I swap the bulbs. See, we do have illuminated dials here now, and yeah, it's just out of shot, but you can, here is the power on button, is now also lighting up, and this is the mono. Yeah, there you can see the mono stereo light is also working now. Well, 2 bulbs were out, and as I already explained in the previous videos, the bulbs here are in series, so that means that all of them went out. Now, I don't really have the correct bulbs yet. All the bulbs here, they are 6 volts 50 milliamps, and so these are the original ones that came out. Let me focus here on this. See, they put some heat shrink over here to reduce the stray lighting a bit. But these are the original ones that came out, and as you see, they have a bit of a lens here on top. Those are the ones that came out of the VU meters. They are balloon type. I swapped them with these normal bulb styles, and they are a bit too long. They don't fit in all the way, and they also are a bit more dim than these guys, which is a bit weird. But for the moment it works. I'm just gonna try and find these balloon, yeah, no, with the lens here on top, I don't think I will find that, but at least the balloon shaped ones. So this is how they were in the VU meter, and here this is how they are in the indicator for the power and the stereo button or the stereo light. See, they don't have this lens shape. Those are regular balloon type bulbs. Yeah, that's interesting. But for now we do have lighting, so now I can already more easily see when I have the amp turned on, so that's good. But the rest of the lighting I will do some changes on the lighting circuit, but that'll be for the next video. Now, there is something else which broke. If you look at the meters here, let me zoom you in a bit. So if you look at the meters, let me turn on the amp here. See, they seem to be working, both. Now I'm talking about the meter itself, not the lighting. And I have the, let me put it on, yeah, the amp is on mono, so both channels should be identical. I'm feeding in a tone now from my signal generator, and see, only the right meter is working, the left meter isn't working anymore. And that happened while I was working on it, so that one decided to stop working. I think I know why. Let me just get you a bit closer here. Okay, so let me first show you here the metering circuit. So this is the circuit for the meter on the right channel. See, here is the VU meter. Here on the left channel, the circuit is identical. Now, as you see, this circuit is driven by this transistor. That's an AC127. It's a germanium NPN transistor. And I believe this guy here on the left channel is bad. Now, if you want to spot check a transistor, just do a quick check if it is shorted or not. Then it's very easy to do with your multimeter. You put your multimeter in diode test. You put one lead on the base and the other lead on the emitter or on the collector, and you should measure one diode drop across it. And in the other directions, you shouldn't measure anything, or you should measure higher than a diode drop, because that means then that you're measuring across some other parts of the circuit. But you should definitely not measure like a short between any of the leads. What is very common is a collector to emitter short, for example. If you measure 0 between collector and emitter, you know that something is wrong. Now, if it is in this case an NPN, then you should put the positive lead on the base. If it is a PNP, you should put the negative lead on the base. It's very easy to remember. You just look at the middle letter. So in this case, NPN, so it means P on the base. You put your positive lead on the base, and then you measure with a diode test to the other leads. Now let's do that. I'll put my multimeter here in diode test, put my positive lead on the base. So it's these two guys over here. This is the one for the left channel. This is the one for the right channel. Now in this case, let me quickly take the pin out. Oh yeah, important here to note is that here in this circuit, you see that the emitter is connected directly to the base. So here in this case, it doesn't really make sense to measure between base and emitter, because yeah, you will see a short anyway between those two. So we're going to measure between base and collector. See, so here we have the pin out. So the top one, or the one that sticks out a bit, is the base, and then we have on the left emitter and on the right the collector. So if you notice here, the one that sticks out, that's the base. So we put our positive lead on the base, and then we measure to, like I said, collector, and we measure, wait, am I looking at this incorrectly? Maybe? Yeah, that's the emitter. Yeah, I was looking at it incorrectly. This is the emitter, and you see that short because they are just connected together. That's the collector over there. It's .125, so keep in mind that this is a germanium. So on a silicon transistor, you will see a .6 or something. This is a germanium, so .124. If you measure the other way around, base collector, wait, I'm not touching it, there it is. See, you measure something much higher, which is not, yeah, it's normal. If it would be out of circuit, then you would measure open in this case. Now let's do the same thing here on the left side. I'm putting my lead here. This is difficult to get to without the, wait, with my hands are in the way probably. Yeah, difficult to get to without my hands blocking the view. See, there we measure positive on the base, negative on the collector. We measure .03, which is much too low. In this direction, if I swap the leads around, see, I also measure .03, so that's definitely not okay. What is also cool, see, you should see the meters swinging out. If I measure here across this one, see, the meter of that channel is swinging here on this side. Absolutely nothing. Okay, so I'm gonna pull this transistor, and we'll probably determine that it's bad. Okay, so I've got a transistor hooked up to the component tester here. So let's see what we get. It's taking a long time. Oh, wow. It's testing fine. Okay. Yeah, that is testing okay. Okay, look, we are back in business. The problem was with that transistor, but it was physical. So one leg, the base was cracked near the PCB, so it was broken. I noticed it when I tried to clean up the solder holes, or the holes in the PCB. I noticed that there was a tiny bit of the leg still left in there, so it must have been cracked off. I think I must have broken it when I was cleaning this PCB. So I just put the transistor back, soldered it in decently, and it's working now. Awesome. Are you kidding me? It's gone again. It was working, then I powered up the volume until I went more or less 2/3, and then this one dropped again to 0 and it stopped working. So is this transistor going flaky perhaps? Because now I measure the same thing. Let me turn off the amp here before I measure this, but see, I again now measure here between base and collector this 0.03 volts. It's, yeah, you probably were not able to see that, but see, 0.026. Alright, so that transistor needs to be replaced, I think. The issue is I don't have any replacements or any equivalents in my stock. I checked all of my germaniums that I had. Nothing seems to be a good alternative or a good equivalent, so I will have to place an order for that. So hopefully we'll get that fixed in the next video. Now, in the meantime, I hooked up my distortion meter, and yeah, see, it's up there. And let me get you a bit closer here on the distortion meter. Okay, so I have a 1 kilohertz tone going into the auxiliary input, and I have the distortion meter connected to the dummy load on the, which channel? The right channel, I believe. Yeah. Oh, maybe I have the amp still set in mono. Maybe I should disable that. Yeah, now the amp is in stereo, so we only have a signal on the right channel. Okay. Now the signal that is going in at the moment, or no, the output signal is 1 volt RMS at the moment, so it is rather low, and my leads that I'm using here are not perfect. I guess they will introduce also a tiny bit of distortion. Also, my meter, I'm not sure how well calibrated it is. It does need a bit of work, and it's still warming up because it hasn't been running for a long time. So now where these spikes are coming from, I don't know. Maybe it's interference from me, from my hand getting close to the circuit here. Maybe it's the amp itself. I'm not really sure. Now, or it might be the meter as well that is still warming up, or that still needs to stabilize. But what you're seeing here is I'm on a scale of, so the top scale of 1%, and so the numbers that you see here on the top is what you should look at. So that means we are now at around between 0.2 and 0.3% of distortion. See, it's fluctuating a bit. I think it's because I am moving around or because of some interference here on the bench. Not sure. In any case, yeah, I do need to adjust the meter here slightly from time to time. But in any case, if we crank up the volume, then I expect it should get better because the signal to noise ratio will be higher, right? So let's maybe go to 2 volt RMS. Yeah, you cannot see this, but on the scope I'm following now, this is exactly 2 volts RMS, and that should be a bit more stable because the signal to noise ratio is higher. And then you see here that it's basically wiggling around 0.2% of THD, which is, let me check here the specifications. I think that's what we expect. Yeah, so right, so here we have the specs, and you see harmonic distortion is less than 0.1% for 2 times 20 watts, okay. And less than 1% for 2 times 30 watts. Okay, so it should be even lower than what we are seeing here. Now again, that could be due to my setup, but yeah, let's crank it up a bit more, because 2 volts, it's not really that big. Let's go to maybe 4 volts. This is 3, this is 4 volts, and now I should go to a higher scale here and let the meter balance out. That will take a while. And yeah, it's not fantastic. Okay, well, that is a lot better. I'm at the 0.3% scale now, so you should look at the lower. Yeah, there is here a scale indicator, so this green LED indicates which scale you should look at. So in this case, the lower scale, and I am on the 0.3%. So we are now measuring here 0.06%, about 0.06%, and I have a voltage of, let me show you the scope so that I'm not lying here. It's about 3 volt RMS, and I am into an 8 ohm load, and it's pretty stable. What I did is I changed a bit the cable from the signal generator to the amplifier. There is a connector in between, and I put some metal tape around that to shield it. And also I grounded the other channel. So the input of the left channel, which is unconnected, there I grounded that one to to chassis. They do recommend it in the manual of the distortion meter. If you are measuring one channel, then you should ground the other channel. I also increased the volume of the signal generator a bit. I'm now feeding 1 volt RMS into the auxiliary. And yeah, so I've got 3 volt into an 8 ohm load. So that's about 3 times 3 is 9 divided by 8. It's a bit more than 1 watt. So this is really the low listening level that we were talking about earlier in the previous video. If I put a scale on 0.1, then wow. Seriously? Is it that low? I think I'm getting here a warning that I'm out of range for the for the voltage. I'm out of range for the voltage because I am here on the 3 to 10 volt range, and the voltage going in is only 3 volts, or is less than 3 volts, so I should go a range lower perhaps. Let's now let it rebalance. Yeah, see, now the warning is gone. And oh, now it's dropping even more, I believe. Let's go to the 0.3. Yeah, we are about the same thing as before. So 0.06%. And so I should also be, yeah, see, now this upper range is correct. Yeah, indeed. Now I'm on the 0.1% scale. you should read the upper range, and indeed we are at, oh, I bumped something there, at 0.06%. So, you know, that's impressive, I believe. You have to keep in mind that we are looking here at an amplifier from 1973, right? So that's quite impressive. And this is what I was talking about in the previous video about this amp running in Class A mode at low listening levels. I think that's what we're seeing here. They state that it should be less than 0.1% for 2 times 20 watts, and that's what we have over here, right? So let's crank it up a bit. Let's see, I'm going now to, this is 6 volts RMS, and then you see I'm getting a warning here that the input voltage is higher than my scale, so I have to go here to this and let it stabilize. And see, we're here still below 0.1%. We're at 0.082 or 85. Yeah, it's half-wave between 8 and 9. So 0.85% at 6 volts. Let's crank it up even further. I'm now at 8. Yeah, the meter isn't even budging, but I am not lying. See, we have here now 8%. Let's crank it up to 9. So this is 9 volt into an 8 ohm load, and you see it's still 0.08% of distortion. I like this. I really like this. Let's go to, let's see, my dummy loads will be getting, yeah, they're getting quite warm, so let's not have this last too long. So this is now, oh, the volume control is really quite twitchy here. So this is 13 volts, and now I again need to increase the scale here. And I believe that now we will not be getting this extremely low. Oh, will we? This is about 0.1. This is almost exactly 0.1. See, it's just slightly higher than 0.1, and you have to keep in mind that yeah, I also have the noise floor because there is noise from the signal generator. The signal generator is not perfect. There is noise from the leads. So, and it is here now, yeah, let's say it's 0.1%. And I have now a signal of 13 volts RMS. And that is 13. Now, granted, I'm only driving one channel here, but divided by 8, that's 21 watts. So we are meeting our specification easily. That's impressive. Yeah, I'm gonna turn down the volume here again because my dummy loads are getting quite hot. Wow. Yeah, I'm really impressed by this amplifier. Now, this was the right channel. Let me do the measurement, the same measurement on the left channel, and I will report if I see the same thing on the left channel. Yeah, so I was not planning to show you this if the measurements were the same, but this is the left channel. Mind you, we are on the 0.1% scale here, so I'm at around 0.02% of distortion here at a 5 volt RMS output signal. So it's even better. Let me crank it up a bit. 6 volt RMS, 7 volt RMS. Let's go up a bit. This is 10 volt RMS. Let's change the scale and let it stabilize. 0.025%. This is, yeah. We're now at 13 volt RMS, still dead on 0.025%. And if I drive it up a bit further, there we go into clipping, see? So this one is even better. It's around constantly between 0.02 and 0.03%. That makes me think that the right channel can even be improved further, but I don't think I'm gonna investigate that because it's meeting its specs and I don't want to, make it worse. So that's really fantastic. And this is at 10 kilohertz, and there we are also below 0.1%. If I go to the 0.1% scale, we are at around 0.06. See that, so that's also perfect. And this is 400 hertz, 6 volts RMS, also 0.03% of distortion. Yeah, this is a really good amplifier, really nice. Okay, so this is something else. This is the pickup input or the phono stage that I'm now using, and I have a 5 volt RMS tone. 5 volt RMS signal on the output, and I am supplying a 30 millivolt RMS into the phono jack. And mind you, we are here on the 3% scale now, and I am above 1% of distortion. What if I crank it up? Let's see. Don't know why I get this warning now, because I only have... it's dropping out. It's because it was increasing probably. But see, if I crank up the volume, the distortion is going up. I'm now at 1.5% of distortion. And I am at 8 volt RMS, more or less. Let's crank it up to 10 volts. And I am at 2% distortion. See, so now could be that, the amp is sitting open here right now, so it is probably getting a bit of distortion from now. I'm turning down the volume again now. It's getting a bit of distortion probably from the surroundings, but still, that's not great. But let me show you something that I found online. It's really very interesting. Okay, so I got here the official service bulletins from Philips, and it's quite a lot. Now, granted, it's in a lot of different languages, but I think there are like 4 in total. This is the first one, and yeah, this one is only in Dutch, or I found it only in Dutch. But they say here, to reduce distortion, change R331 and 981 from 10K to 5.6K, and R34 and 984 from 12K to 5.6K. So that's already something. These are just corrections in the documentation, so I'm not gonna worry about that. But this is by far the most interesting one. So it's also in English, so I can show you. So that's the second service bulletin, and they mention see, change transistor 422 and 442 with the BC149, sorry. And the following list of resistors have been changed with metal film to reduce the low frequency noise. So they propose here to change a couple of transistors and resistors indeed to reduce the noise or the distortion. And then they say, okay, for reasons of production, a couple of resistors have been replaced, so we're not going to bother about that. And then there is a resistor here that say should be replaced with an 8 watt one, because a 5 watt one is dissipating too much. That's one on the output. So on the output, it's related to the stereo 4 function that we discussed in the previous video. So for the moment, I'm also not going to worry about that. These are for other models. So the 621 is for another model. And here we have the same explanation, but in different languages. Now what I did is I highlighted here on the schematic everything in yellow, which I just mentioned. And let's start over here. So these are the ones from the first service bulletin. I'm just going to show one channel here. I think that's a lot easier. So it's this one and that one. They propose to change it to a 5.6K. And as you see, it's a preamplifier, I believe, yes. Because see, this is your, come on, tone shaping circuit. Because here you have the volume control. Here you have the bass control. This is the balance. If we go even further to the left, here is the loudness, or what they call the, what's it called again? The contour. That is this section. Here is the treble. And there should be also the presence control, but I can't see that one at first sight. I think it's that one over there, but it's not marked. Anyway, you see the tone shaping circuit in this amplifier is quite elaborate and quite complicated. And in the previous video we saw some issues with, well, what I thought was issues, where the volume was going up and then it was stopping for a while, and then it went further suddenly, and then it stopped again when you turn the volume knob. And that's all related to this contour or loudness control. Because you see the volume pod is something really special. It has two loudness taps. So it's a volume control or a potentiometer with 5 taps. So you have an input, the other side is connected to ground, here is your output, and then you have 2 loudness taps, and depending on the position of this switch, because this is one switch, this is the loudness control, you switch in all these different kind of networks of resistors and capacitors to change the frequency response of your volume control, and it's quite complicated. But so what they propose to do is swap these values of these resistors. Now that here the collector resistor of this amplifier, this preamp, and the emitter resistor. So I guess then this will amplify a bit more. I think so. Then here we have these ones. They propose to swap these ones to metal film. And then the most things are actually in the phono stage. So here is the phono preamp, and there they propose to change these 3 resistors to metal film and replace that transistor from a BC148 to a BC149. Now the BC148, well, the BC149 is basically the low noise version of the BC148. So I think it's a bit of an oversight from Philips that they put a BC148 here. That I would call that a mistake even. These really need to be BC149s, because these BC149s, they're really made for a preamp circuit or a phono stage. So that makes a lot of sense to swap this one to a BC149. So that's gonna be quite a bit of work if I want to apply all these changes. Especially this makes sense. Yeah, let me go to my parts here and see what I have, what I can put in there as a replacement. Okay, so this is a part of my BC transistor stock. I've got the 147, the 148 and the 149. The BC148 is the general purpose version. The 149 is the low noise version. And the 147 is a bit higher voltage and higher current rating. So I think it can go up to 50 volts instead of 30 volts. These are intended mainly for audio driver circuits, and these other ones are more general purpose. And the 149 is low noise. Now, the 107, the 108, which I don't have here, and the 109 are equivalents. They are exactly the same transistors, but in a different package. See, these are in this older style package. Let me just show you. See? But so the 107 is the identical to the BC147, but the 140 series, they are in this lock fit packages. See? Same thing with the, but then I need to go to another box. The 5 here. So the 547, 548 and 549. So I don't have the 547 here, but I do have the 548 and the 549. I have one 549 actually. It's again identical transistors, but in a different package. These have the more modern package. But they are also identical. So you can replace, for example, a 148 with a 548 or with a 108. So these are all identical transistors. Now, in my stock here, I only have, so I do not have, I only have one 549 and also only one 109. But I have 4 149s. So, yeah. Now, I know that these lock fit transistors, that they do have a bit of a bad reputation and that they get noisy over time and that they are not really guaranteed to be perfectly fine. But it's all I got at the moment. So, yeah. And it also would look original in there. The ones I have here are also reused and they are made by Siemens, all 4 of them. So I don't really know. I'm still thinking about this. Yeah, let me know what you think, because I do think I'm gonna stop the video here. I think the video is long enough. I will do these modifications that they mention here on the schematic. I will do them offline and then I will report back in the next video to show you if it had any effect. Now, let me know what you think. I am in doubt a bit about these lock fit transistors because if they go bad, they don't really well, they also obviously can short or really short out, but they can also just become noisy over time. So that's why I'm hesitating a bit to use these in a low noise circuit or in a preamp. Anywhere else where they are just like a signal transistor or a switching transistor, they would still be perfectly fine. I don't think you will even notice the fact that they are going bad. But in a low noise circuit, not sure, maybe I should order a bit of, now this one is stuck here on my tweeter, maybe I should order a set of BC549s. That might also be, that's maybe the best option. So maybe I'm gonna do that, order a couple of BC549s and replace those 148s in the phono preamp with 549s. Yeah, I think that's the best option. Anyway, so I am going to order those. I'm also going to order here a replacement AC127. I'm going to try to find the correct bulbs. And then hopefully when I get these components in, then we can replace them, or I will replace them and we will check in the next video if we have a lower distortion on the phono stage, and I will also get the dial lamps to work correctly. So that's it for now. Then unfortunately I'm again a bit stuck until the components arrive, and then I hope I'll see you in the next video. Okay, so this is something I didn't want to keep from you before closing down this video. For the first time I'm playing actual music now through the amplifier. And everything is working fine. Balance. And these are the, wait, that's the bass. Yeah, now just the portion of the music is low in bass, but that's the bass, that's the presence. And this is the treble. And what is striking is the difference in the sound with these 4 settings on the contour control. And keep in mind, I have very tiny speakers here in the workshop, so there shouldn't be any bass with these small speakers. So on a decent pair of speakers, this will sound even, well, this will sound much better. Let me get the microphone a bit closer to the speaker. Yeah, I kind of like that. I'm just gonna sit here now, listen a bit to it, because I really like how clear it sounds. And yeah, even though it's on my tiny speakers. So yeah, I'd like to thank you for watching. And I hope that we can finish it off in the next video. If I get the parts, I'm gonna go ahead with cleaning. There are still some things I need to clean here. The front panel, I already started cleaning that. And then the sides, the wood, I need to do a bit of, yeah, apply a bit of wood finish or some oil to rejuvenate the wood here a bit, because there are some scratches and it is a bit discolored. And also cleaning the side panels and the top panel. So those things I will do offline, and then hopefully in the next video you'll see the result. So thanks for watching, and I hope I'll see you in the next one. Bye bye.